That's execution. Well, it's execution still, but see the time of them, here's our time delay. See?
So timing and then okay.
Let me tell you how much you set the time to. Oh, 0.1 second.
Okay, I see that. Yeah.
Once you drop it in there, that, alright?
Alright. So since we do that, so switch back to the front panel and run your programs by clicking the white run arrow in the top left of your screen. So adjust the two knobs and notice the change in the generated wave.
Alright, so if you notice the little run button is broken. You can see that? Here.
Yeah,
Black camera, the front panel, it's on both. And it will not run. You see that?
Here.
Yeah, everybody feel partaking, man. Sit and observe, you know.
Go over that one. I never see that one. Go back to that.
The arrow, there's a run arrow. Wait, Bruce, I'm not hear your voice.
Where you, man?
I know, jam on me attack, man. Bruce. Bruce, anyhow. Yeah, you see the arrow is broken, right? So that means there's something wrong with the code. So it cannot be executed. I don't know if it's a version problem. Well, this tutorial don't show you. But right here, you see the stop button? Everybody see it?
Yeah.
So right click it. And we're going to press create control. Yeah? Right click create control and then the stop come. And now look at the button. You run and you realize it is not broken again. Yeah?
Yes, sir. Yeah.
So now we can press run. And we can adjust the frequency now. Cool?
Yeah.
Yeah. So these are the things. Yeah, online labs, sir. Alright, so as I can say, the graph now display the waveform. I wish I could actually give a control one can actually move them on yourself, but ask some questions, you make the adjustments to the code or to the graph, whatever. Phone the time now. Not audible. Yeah. So there was a you need to add a control to the stop button. I'm right click it and press create control. Go again. The stop wasn't there. there was a broken arrow for the run button. You see it? So loop condition terminal is not wired. So let me read this. It said the conditional terminal is not wired to anything and must be wired to a Boolean data source. Such a button or the result of a comparison. And you need it, you think they set up in a so now let me have more with you them sir. Online? Yeah. I'm gonna run it with the man them. Tell what I can have done. See you then I have now in front of me. A little tutorial I'm gonna show them man. You know, I'll be like married sir. Yeah, me. Yes, they go to tutorial now. No. Yeah, but me take them through the tutorial. Me have a look why I forgot this connection. I'm sorry about that. So, you understand what I mean by conditional terminal is not wired?
That means there is no condition to stop the loop.
Right. It kind of, you can click show error. Well, just highlight the loop.
Like if you have multiple loops, so you could select this one.
I'm here trying to wonder if. Okay. So look at this now. Let me show you something. So one might ask, what conditional terminal? What is meant by that? Yeah. So clearly, when we click show error, it just highlight the loop. But if you look and when we press help, here it show you conditional terminal. See them have a sign here, so symbol or the stop. You see? Hello?
Yeah, we're seeing.
Yeah, we're seeing.
Right. So of this for loop or while loop is not wired to anything and must be wired to a Boolean data such as the button or result of comparison. So you must wire a Boolean value to the conditional terminal to control if the loop stops or continues. So see it here. To correct this error, right click the conditional terminal on the block diagram and select create control from the shortcut menu to create a front panel Boolean control. Wire the Boolean control terminal to the conditional terminal. You can also wire the output from the function from the comparison palette. So this is where you can find a solution. So if you have an error in your code, and as degree students doing engineering, depends on where you go, you might be required to set up such a system. So just so you know, you have to read your help context. You have to do a little research to find out what's the issue causing your program not to run. Alright? So as they say, you right click the conditional terminal here and press create control. See? Boom. And see a stop come here, so. And here is it. So I'm gonna press run again. I can see the graph now running. Any adjustments you would want to make before we move on?
Not really.
What if you change the time?
You ever change what?
Time away from 1 second.
To what? A 0.1 doing.
No, maybe 0.5 now. Change it also.
Oh, the slow down. Okay.
Mm-hmm. Never asked that either. So I go on?
You kind of figure because you say as fast as the processor can
Precisely.
carry the wave.
Precisely. So it just make it doable. It's a frequency. Yeah. And amplitude can get changed. Are you all good with that?
Yeah, man.
Yes, sir.
Alright.
Yes, sir.
Alright. So we have to make some connection. So bear with me, yeah? We'll make some connection. Something DAQ. Yes, second. Alright. Let me answer this. Is it clear?
Yes.
Come more on it.
National Instruments. And I can't say the next part on it. USB 5009.
Alright. So, it's one mark here, so?
Analog.
Here, so?
Digital.
Alright, so it's a USB in. So I'm going to plug it into the laptop now. Yeah? There's a little light should be flashing. And then you can see it here.
Yeah.
Alright, so what this does is to hold on, just read exercise too. I'm safe before me talk.
So data acquisition with NI LabVIEW. In this exercise, you will configure a data acquisition device, use it with the DAQ assistant, and take measurements with NI LabVIEW. Set up the hardware, connect the NI USB 6009 DAQ module to the PC using a USB cable. It's an NI DAQ MX driver installed on the PC. Automatically, it detects the USB DAQ module and brings up the following window. And then it's just if you open the LabVIEW, press Ctrl N to open a blank VI, press Ctrl T to tile front panel and block diagram.
Alright,
window.
so you go create. So then basically one will create another project or another blank. Okay, so we will close the current one. Yeah. I'll close this. Save it. So. Alright, so I'll create a new blank there again. So I have a few things for wire. Just give me a second, I get a screwdriver and come. Alright, so here it is. Terminal. Alright, ready again. You can go ahead.
So open that. So it's a press Ctrl T to tile front panel and block diagram windows.
Yeah, I already do that. Put them side by side.
Pull up the functions palette by right clicking on the white space on the LabVIEW block diagram window. So move your mouse over the Express input palette and click the DAQ Assist Express VI.
So input DAQ assist. You see? Everybody clear before we move on?
Yeah, I've seen it.
So to configure a voltage measurement application, click on the analog input voltage and then click the plus sign next to the USB highlight channel AI0.
So the first thing would be acquire signal. So acquire means input a signal to the DAQ that you want to display on LabVIEW. And the generate signal when LabVIEW now is going to give out an output. So from the DAQ, it would output a signal. So acquire and what them say next? Analog input.
Yeah, analog input voltage. So click the plus sign and then AI0.
So this
analog
means
input 0.
Analog input 0, precisely. And then finish, right?
Yeah, finish. It says now to change the minimum to 0 and the maximum to 5. And the acquisition mode to continuous.
Continuous.
So click OK and close the Express block configuration window to return to the LabVIEW block diagram. Notice that LabVIEW automatically creates the code for you for this measurement task. Click yes to automatically create a while loop. Right-click the data terminal output of the DAQ Assistant Express VI and select Create Graph Indicator. I'm seeing a create under signal manipulation.
Yeah, see them.
Yeah, okay.
Yeah.
Notice that a graph indicator is placed on the front panel. Your block diagram should now look like the figure below. The while loop automatically adds a stop button to your front panel, and that allows you to stop the execution of the loop. Rather than displaying our data in a graph indicator, we want to display our temperature readings at thermometer indicator. To do this, go to the front panel by pressing Ctrl E. Right-click the graph indicator and select replace.
So this is the graph indicator, right? So right click and press replace.
The controls panel will appear. Select modern numeric thermometer.
Yeah, see?
Yeah. Modern numeric, okay.
That's it. Can resize it.
So also you could click on the stop F button and select replace.
What?
It's saying an alternative is to select the stop F button and select replace.
You did see such a.
It's right above the thermometer.
Oh.
Replace down here, sir. Now it's saying to select the Boolean stop button. Okay. Continue.
Yeah.
Modify the thermometer indicator by right clicking it.
Must it this now? Oh yeah, stop. So okay. Go on.
Modify the thermometer indicator by right clicking it and selecting properties. On the appearance tab, change the label to temperature.
Oh.
And click OK when you're finished. To switch to the block diagram, expand the while loop.
This is a. You don't need that though. I'm gonna remove that. Yeah.
Okay. Yeah.
Data. Yeah. Label data. Next.
Next is switch to the block diagram, expand the while loop.
Yeah, I need to do that.
To perform multiplication on your data from the DAQ assistant, select the express, arithmetic, and comparison numeric. Multiply. Mathematics.
Express what?
Arithmetic and comparison.
Oh.
Numeric constant.
Oh, you want to.
You want to multiply, yeah.
I think that see that you know. Multiplier. Yeah?
Yeah, that's easier.
Don't never have to go so far. Oh, so they want to multiply the output by 20. Yeah?
Yeah, multiply the output by 20.
Before I go to the temperature. So you want to read on. I could just take it step by step. Go on.
Well, let's base that alone itself for this, multiply it by 20.
Alright, so I'm going to break this line here. I'm going to delete it. Yeah? Alright, so I'm going to add one leg to the x value of the multiplier and the output to the temperature, right? Temperature display. Now, how would I be able to multiply this by 20 now? See them about 20 here. What would we do here?
The numeric value to the multiplier.
Huh?
Yeah, add a numeric value to the multiplier.
How?
By adding the same right click and numeric constant.
What? So create
Yeah, create constant.
Alright, so that's it. Huh? What now? Continue.
So to perform the analysis on your data, select the express signal analysis statistics. So express, then signal analysis, then statistics.
Nothing is a
Signal analysis, and then statistics.
Just that's my blood there. Alright, boom. Your time.
A properties window will appear. Make the following selections and click select OK. Statistics calculations, arithmetic mean. So for the statistics calculations, select the arithmetic mean box.
Oh, hold on. Let me just go and do them. So them are arithmetic mean.
And extreme values to be maximum and minimum. And minimum.
That's alone.
Yeah, that's it. Right now, so to connect the data output from the multiplier to the signal input of the statistics BI.
Alright, so here we have the signal. You see that? Blink.
You can see.
Yeah, we just carry it up and add it to here. So we are sending signal now to two places, statistics and to the temperature display. Fine.
Right click the arithmetic mean output of the statistics VI and select create numeric indicator.
Right. Oh, the mean output. Okay. Numeric indicator. Boom. Same thing. Yeah, same thing. Alright, so you see them come up over here, so now?
Okay.
Yeah? Talk to me. Ready again.
To rearrange the signal. Let me see. Rearrange the controls and indicators to resemble the following.
Wait there now.
Part 25.
Oh. Okay. Go to that.
I think the stop if we should have changed it to the Boolean stop. We should replace the stop if.
Wasn't it a choice?
Now I'm seeing in the picture now where is a big stop inside of the stop if. The Boolean stop.
Good.
Yeah. All right, so it says to save the VI in the folder by using the file menu and name it exercise 2 VI. Now it says to run the VI, turn the potentiometer knob in both clockwise and anti-clockwise direction, and notice a change in temperature on the thermometer.
Alright, so them never tell you this now. So again, I have to make some adjustments here. So right here we have a potentiometer. See that? Alright. So basically it's a 1K part, right? So on one leg, we are gonna attach the power source, right? Here. And the other leg, we are gonna attach the 0 volts, and then on the middle pin, we're going to send this to the input where we did select the voltage input. There. Yeah, man, you know what part work, right?
Yeah.
Alright, so I'm trying to make a connection now. You can see?
Yeah, we're seeing.
You know, oh boy, I'm in a team did record this session, eh? So everybody must partake.
So analog A0.
Alright. So if you look here, let me know if you can see. There's some markings along the top.
Yeah.
Alright. So, and then on the DC side, we have 5 volts. You can see that?
5 volts and 2.5 volts, yeah.
Yeah, right. So I'm gonna connect one of the pin them to the 5 volt. Other pin to negative. Actually ground pin. And then we need to extend this. So extend it to another piece of there. Analog input 0, right?
Yeah.
So I can say?
Yeah, we can say.
So analog input 0. So now connect that. Let's see what I'm saying with the lab now. Must run it now.
Yeah, run it and turn the potentiometer now.
So yeah, it's now running. So I'm gonna turn the pot. Spring. Just turn it up. Alright, so you can see what's happening while I'm adjusting the pot.
Yeah, temperature drop.
Yeah. And then turn it again. Turn it up.
Which direction? Like clockwise, anti-clockwise, when you burn it.
Alright, so this clockwise me I turn it now.
So you go up the clockwise, down the anti-clockwise.
Yeah. So I'm going. Alright, so if we had wanted to go all the way to 100, what kind of adjustment you would have make?
Increase the other input or the multiplier.
Alright. So how much? Frida?
Oh, no, not too sure. What's the maximum now? What the maximum
20.
go to now?
They are 20 now. The maximum point temperature are 100. But the constant, the multiplier 20. Come on, just give me a value.
What's the question again?
Huh?
What's the question?
Say, when the input potentiometer reaches its maximum value, we are still not at 100 on the display. I'm saying, what would we do to get it to go to 100?
All right, change 25.
Run. Not there.
So then it's 30 then.
Repeat.
You probably can just double it, so
30. Change it to 30.
Max out. Yeah, you reach. So, apart from using a constant, right? Let me see something. Replace. So, numeric. So last time I create a constant, right? So we can use, I think is control So run. Select now. Multiply 20. Yeah? Yeah? Hello?
Yeah, man, we see it.
Yeah,
We
man,
see it.
that's the right answer.
Yes, sir. Yes, sir.
So,
See it, man.
sometimes you collect some data. You can just use like the control. See it? So this would be better for you. Instead of you have to stop the system every minute to change the value. You get me?
Yeah, yeah.
Right. Oh,
Yes,
we
sir.
finished. Yeah. So right now,
Quick question, sir.
yeah.
All right, so in the case that it's actually change the number to 40, right? Would it be that you would actually increase the potentiometer smaller to actually get it to 100?
Say that again.
All right, so if you change the Y value to 40, right? Would you wouldn't have to turn the potentiometer to its max to actually get it to 100, right?
No.
All right.
So what it is doing, it is multiplying the value, the voltage coming from the potentiometer. So if you change the multiplier within your program, the output is going to be more.
Okay, so noted.
Mm-hmm. So yeah, so that really take place. Alright, so like we reach the end of the tutorial, we can ask questions. If you want to change anything, if you make anything more straightforward, go ahead. Was all clear? Remember, I actually forget to record the session, so do a no questions?
Yes, sir. Where you find this program? LabVIEW.
National Instruments.
It's online or you have to download it?
Yeah, man, you have to download it.
All right.
For question, so this is basically the tutorial, or is this, well, it could be the actual lab? We're going to get a lab based on this next week.
Yeah, the lab is gonna be a little bit more complicated. However, with the tutorial, you should, be familiar now with LabVIEW and how to operate it, how it actually works. You understand? In terms of linking the DAQ with the software.
So, question. For the actual lab, we won't be doing any DAQ because we won't have the hardware to use with our computers.
Yeah, so I'm thinking I should just let you guys come into the lab next week. So last week, repeat?
So the protocol that was before that what email was sent, that is no more in place, you see?
Yeah, we should come half and half, like for the first hour and a half.
No. There was an email sent by the head of school about no face-to-face class. He said that is no longer an issue.
We just receive I receive an email that we are good to go again.
Hey, Matthew, can you go over where you get that the Y value?
This value you're talking here?
The one that's on the display where it said it's easier to manipulate that other than stopping the system.
Oh, so right click the input to the multiplier and press create control.
Okay.
Okay, so this is the control that you see now, and on the front panel is where you input the number. Note you could just click it, go to numeric, and let's see where this is. Maybe it wouldn't be on this one. Numeric. Alright, so numeric control, here it is. Yeah? Numeric control, drop it there. So this can enter the value, and you would have to now link here with the input for the multiplier. You see it?
Yeah, man, seeing it. Thank you.
Cool. Likewise, you don't necessarily have to use numeric indicator. You could use a dial or the knob. See? So really this. So we could link the knob here. We could go to the properties of the knob and go to scale, set the maximum to let's say 40. So we run this now. So now it's at 0. So see? So good?
Yes, sir.
Yeah, so you can use the knob to change the value. So now the knob is at the maximum. So if I adjust the potentiometer now, it will go up. Yeah? So it all depends on the interface that you want to create. I'm going to post the final lab in the same folder.
Okay.
So watch this.
Okay.
So as I said, next week, based on the schedule for the very first lab, you have the first 8 students come from like 9:30. And then the other 8 students come from 9:30 to 12. What?
All right, cool answer.
So until next week. So you're not going to come to the lab next week.
Repeat the time.
And they send out a schedule in the group that was the very first lab. So it allow the first 8 students from that list to come from 9:30 to from 9 to 10:30. Then the other eight students come from 10:30 to 12 o'clock.
All right.
Yeah, so just go back, visit the schedule. Are you supposed to know which time you did come for the very first lap? So we're going to use that.
Yeah, man.
So next week, when you come and that will be your final lap. Alright?
All right, G.
Okay, cool. And
Yeah, man. Lab 1, Mark 2, so send out the grades. It's just, we need to get all the students on board. So, we'll get some replies. Alright?
okay then. Yeah, man.
So if there's no other questions, that will be it until next week.
Alright, so. Alright, next week.
Okay.
Alright, cool.
That's next week.
Alright.